power. And the more the investment, the better will be the reliability of the electricity supply system. So you can see this blue line, and in the horizontal axis we have reliability. So reliability is increasing as the blue line or more investment is made. This vertical axis represents the cost. Okay, this represents the cost. So blue line and the reliability, and this is the perfect reliability, that is 100% reliability, and which may not be reached at all. And by this reddish line we have interruption cost or the customer cost because of the low reliability or unreliability of the system. Unreliability of the system. So unreliability is complementary of the reliability. So unreliability minus R. So when unreliability is high, when reliability is low, unreliability is high, and when unreliability is high, the customer's unreliability cost is also high. So you can see in this left hand side, we have high unreliability cost or high interruption cost, and that interruption cost is incurred by the customers. So this unreliability cost incurred by the customer continuously decreases, and it is exponentially decreasing. You can see with the increment or enhancement of the reliability, and when it nears the perfect reliability, this unreliability cost nears zero. Okay, when it is a perfectly reliable system, unreliability cost is zero. So when we add or when we put together those two costs, one is the investment cost or the utility cost made by the utility, and another is the interruption cost that is incurred by the customers, that is experienced by the customers. Okay, so both of those costs have to be attributed to the customers, because they are the ones who will be responsible for paying back to the utilities, because whatever investment utility have made, they must recover from the customers. So all these utility costs have to be recovered from the customers. Apart from that, customer also incur this interruption cost. So putting those together, we get this type of curve, so it's we have a valley, and this is a minimal point. So we have a single minimum that reflects the optimal reliability of the system. Optimal reliability of the system. And I told yesterday also that utilities try to maintain this optimal reliability in the system, but it's very, very difficult to maintain continuously this reliability level. Either the utilities are operating at higher reliability than required, or they are operating at lower reliability than required. But you can see this in the area near this optimal reliability, we have a rather flat part this. Okay, so the cost is not that much changing there. So if it is slightly less than optimal reliability or slightly higher than optimal reliability, cost might not be that much varying. So it is perfectly okay to operate the system on either side of this optimality condition. So value-based reliability planning in a modern power system. Value-based reliability planning explicitly incorporates the cost of customer losses in the decision-making process. So when when we decide on making any additional investment into the power system so that reliability level is maintained, we definitely incorporate the customer cost. Okay, we have to incorporate the customer cost, and the customer cost is nothing but that is the customer interruption cost, because the utility cost is always, utility has control over the utility cost, but utility does not have control over the customer cost. Okay, so who will make the investment in the system? That utility will make the investment into the system. So to improve the reliability of the system, who will make additional investment? Utility will have to make the additional investment. So they have control over their investment, but they don't know what is the cost of customer, so they need to know what is the cost of customer, so that the investment made into the system results in optimal reliability of the system, because it is the total cost burned by the customer is nothing but this is a societal cost. This is a societal cost, so cost to the society. So it is always in the interest of utility that the societal cost is kept at minimum, because if the utility tries to raise the rate of electricity sold to the customer, then there can be backlash from the customers, so they have to avoid that situation also. But if the utility is serving poor quality or poor reliability electricity to the customers, then again there can be a backlash. So they have to defend from both the scenarios. They have to avoid having over investment in the system. They have to avoid under investment in the system. So they need to know investment cost. They know because they are investing. So they need to know also the customers' unreliability cost. Okay, so that will help them to arrive at the optimal or minimum investment required, optimal investment in the system. That is the minimum investment required to maintain the optimal reliability in the system. So this approach involves the ability to perform quantitative reliability assessment of the power system or subsystem and to estimate the customer outage cost associated with the possible planning alternatives. So we need to know what are the possible different alternatives available and what are the costs associated with those different alternatives. Means what are the costs? Means investment cost as well as unreliability cost. Because for different planning alternatives, if I make over investment, unreliability cost will be low, but the total cost might be high. If I make under investment, then again unreliability cost will be high, investment cost will be low, but the total cost will again be higher. When I make investment that results in optimal reliability, then the sum of investment cost and the customer interruption cost will be at its minimum. So that we need to find out, and based on that we need to make investment decision in a modern power system. So what are required for this approach? Data concept and requirement for value-based reliability planning. Basic data sets. We need relevant component outage data. Means for all the generators, we need to know the force outage rate. That definitely we will be knowing. And if there are other components as well that needs to be considered, their force outage rate data also needs to be known. And customer interruption cost data. So we need to know the customer interruption cost data. Means what are the costs to different categories of customers because of electricity supply interruptions. Electricity supply interruption. And by electricity supply interruption, we mean sudden interruption without prior information. If there is a supply unavailability, but there have been prior notification of that supply unavailability, that is not called interruption. That we call scheduled outage, scheduled supply outage. But if there is electricity supply interruption without any prior notification, this is an outage or unscheduled outage. Okay, so this unscheduled outage has more cost compared to the scheduled outage. And quantitative reliability evaluation techniques, we need to know how to evaluate the reliability. Okay, and the impacts of interruption. There can be direct cost and there can be indirect cost. So as I mentioned earlier, the direct cost in case of industrial unit, it's the losses incurred by the industry. Indirect cost means like cost to the residential customer, even cost to the commercial customer, or even cost to the society also, So impact of interruption, direct cost. So what are the direct costs? Economic, lost production, product spoilage, paid staff unable to work. This is all related to most of the industrial customer. Or also product spoilage may be a direct cost to the residential customer as well. We have a refrigerator at our households, and we store, food products in refrigerator. And if there is a prolonged outage of electricity supply, then that product in the refrigerator can be spoiled. So that is the cost of product spoilage, so that relevant to the residential customer as well. But mostly this is related to the commercial and industrial customers, But at residential level, the product spoilage cost might not be that much high. And social cost, So what are the what are the social costs we have? Like we have transportation unavailable. Yeah. So it comes into the indirect cost. So what are the indirect costs? Economic cost, changes in business plan and schedules. So social and relational, there can be looting because of unavailability of electricity. So if a popular serial or a popular sporting activity was going on and there is a abrupt unavailability of supply, then it can cause looting or rioting also in some cases. If there is a prolonged electricity outage, it can cause those things also. So, and then there can be some legal cost and insurance cost. So if such provisions are there, then these costs also have to be considered. And because of this prolonged or frequent electricity outage, sometimes business owners should think or should start thinking about changes in their business plan. Okay, so these things have to be considered. So, and there are several, like in social, we have transportation unavailable, that is like we are using metro, and if electricity supply is not available, then metro may not be available. So, or other type of electric transport may not be available because of unavailability of electricity, So, risk of injury or death, uncomfortable building temperature because of unavailability of electricity, loss of leisure time for residential customer, and again fear of crime. Again, this is attributed to the residential customers. So there are direct costs as well as indirect costs. So in most of the cases, indirect costs are also significant. Okay, in industrial customers case, direct cost may be more significant, but in other cases, indirect costs may also be significant and they have to be considered. Okay, so approaches used in assessing interruption cost, analytical methods, failure impact studies, and customer surveys. Okay, so various analytical methods, electricity rates to customers based on that, past implicit reliability evaluation in any other countries or any other jurisdictions which have similarity, gross economic indices, so what were the gross economic indices, when electricity supply was continuous and when electricity supply was disrupted for this many days, what is the gross economic indices? Similarly, price elasticity, customer subscription, they may have priority service, or they may have insurance schemes against service unavailability also, and cost of backup supply. So based on that, we can carry out cost of electricity interruption. Okay, what will be the cost of electricity interruption? But customer survey, one of the major focus of customer survey is, customers are in a better position to know what are the costs due to supply interruption. Okay, so that's why customer surveys are a preferred method of determining the interruption cost. So how it is done? Random sampling of entire customer population, statistically meaningful sample sizes by customer categories and subcategories. So if we have different customer categories, then all of them must have statistically meaningful representation in the total customer survey size. Okay, focus study group, especially for customer questionnaire development, because when developing questionnaire, it is very important to include all the issues that may arise during the customer survey. Okay, and the customer survey can be carried out either by telephone. Obviously, these telephonic customer surveys are almost outdated. By emails or by prepaid postal service, in which you will send the list of questionnaire that has to be answered by the customers in a prepaid mail, or in-person surveys. You meet the customers in person and get their answers on the list of questions, or it can also be, or maybe, carried out using the internet. So the questions are there. You have a unique, identification number. Based on that unique identification number, you can participate in that internet-based survey, and you provide your feedback there. So if this last method, this has not been, tested yet, and there is no, credible information available as the outcome of this internet-based survey, but that can be one of the potential, approach or method to carry out the customer survey. So interruption cost evaluation method, I already mentioned direct loss evaluation, rate change approach. So direct loss evaluation is mostly for residential customers, and rate change approach means willingness to pay and willingness to accept. That is, if you are willing to pay higher price to get higher reliability, that is the rate change approach. So willingness to pay means willingness to pay more to have higher supply reliability, to avoid interruptions in the future. So that is willingness to pay. And similarly, willingness to accept is accept inferior reliability compared to the existing one, but in exchange you will get paid by the utility to accept that inferior reliability. So that is the rate change approach. And interruption cost evaluation method, there is indirect evaluation. What we do is, we already mentioned, there is a hypothetical insurance premium for assured supply or compensation for loss. So if you are to get some insurance, and why you need insurance? Because of electricity supply interruption, your product will be lost, or you will incur losses in other forms. So you will get compensation for the loss that are incurred by you. And also another approach is known as preparatory action approach, in which you prepare yourself against the possible or inevitable electricity supply interruption. You know that electricity supply interruption will occur, so you prepare yourself. So what do? You may have a backup supply, you may try to get supply from alternate source if source from the main supplier is not available, So these are the preparatory action approach. Okay. Sorry. So it is very important once you have carried out the survey, it is very important to carry out the cost analysis. So what are the costs? Average reported cost. Who reports those costs? Customers will report the cost. So there are different categories of customer. Residential customer will report one type of cost. Commercial customer will report one type of cost. Industrial customer will report one type of cost. And the cost reported by average residential customer will be very low because we know that their consumption is also low. But the cost reported by average industrial customer will be very high because their average consumption is high. Okay, so they will be reporting their cost. So therefore, it is necessary to normalize that cost based on the demand. Okay, so consumption normalized based on demand or based on their annual consumption. Okay, that is called consumption normalized or demand normalized cost, or weighted cost within a sector and among the sector. Means within a particular sector means within the residential customer itself, or among the sector means residential sector, industrial sector, commercial sector, farm or agriculture sector, municipal sector, government offices or other institutions, and so on. So it is necessary to find those costs. And similarly, we also will see the variation in cost with duration and frequency of outage. If the duration of outage is very short, like a momentary interruption, means how long? Maybe for 2 seconds, sometime, momentarily switched off and switched on. Or let's say 1 minute interruption, or let's say 20-minute interruption, or 1 hour interruption, or 4-hour interruption, or 8-hour interruption, or 24-hour interruption. All of these interruptions, which vary in duration, they will have different costs, because the shorter the duration, the lesser will be the cost of interruption. The lesser will be the cost of interruption. And similarly, how frequently the outage occurs. If the frequency is very high, then cost will be also high. And if the frequency is very low, frequency means frequency of outage, means how many times the outage occurs. If it occurs once in a month, or it occurs once in a year, or once in a day, or sometimes once in a week, or sometimes twice in a day, thrice in a day, So these different frequencies again will have different interruption costs. So, and also variation in cost with the time of day, week, and season. Obviously, when the interruption occurs, for example, now I am delivering this lecture, and if there is interruption in electricity supply, that will cause interruption of my internet service. Then I'll be unable to continue this lecture. So it will have high cost to me, and not only to me, but to the attendees also. So it is when the interruption occurs. So for a industrial customer, when all the workers are there in the industry and they are, starting their shift, if the interruption occurs, they will be left idle. So it will have high interruption cost. For a residential customer, if the interruption occurs during the evening peak, so evening peak in the system is usually because of the residential customers. So during that time, they either are engaged in cooking in the kitchen, or some of them are watching movies or television serials or news broadcasting. So if interruption occurs at that time, the cost will be high. Similarly, for a commercial entity, if the interruption occurs, again during the peak time of their commercial activity, which is usually in the evening time, so again the cost will be high. But if the interruption occurs in the midnight for a commercial entity like a shopping complex, so if the interruption occurs at the midnight, there are no customers at the shopping complex at the midnight. So no losses to the commercial customer or that commercial complex at least. Okay. So we have to identify at what time, if the interruption occurs, what will be the cost. And we always need to know what will be the worst case, So the survey will try to identify the worst case cost, So when the interruption occurs during the peak time, when the interruption occurs during the weekend, when, people are enjoying their holiday, So, or when the interruption occurs during the evening time for a commercial customer, what will be the cost? Sorry. So we need to know. So these costs we have to collect, we have to gather, we have to obtain from the customer survey and analyze them. So again, customer survey, why we prefer customer survey? Customer surveys are preferred. Customer surveys are preferred because we consider the customers to be in a best position to estimate their cost of electricity supply interruption. So customers themselves are in a best position, be it industrial customer, be it commercial customer, be it residential customers. They are in a best position to interpret what are their losses. Okay. So therefore, we need to carry out customer survey because the customers will be providing their responses, So, and I already mentioned that interruption at different time and of different duration will cause different losses and can only be known to the customers themselves. So the customer survey method, though far better than other method, requires large source and time to arrive at usable interruption cost values, because customer survey, you have to have a meaningful sample size. If there are 10 million customers in the system, you need to carry out a customer survey of at least 1% of them, or at least if it is 1%, then how many? It's 10,000. So no, it's 100,000. It's out of 10 million, it's 100,000. So 100,000 customers have to be interviewed. You have to get response from 100,000 customers. That is not an easy task. So therefore, customer survey method requires huge resources to carry out, and therefore it requires huge resources. Therefore, it has to be planned well and, carried well, conducted well. So these methods, contingent valuation, direct costing and indirect costing. So contingent valuation method based on two fundamental concepts. Customer consumes electricity in a predetermined pattern with the time of day, season of year, and is related with the greatest benefit to the customer, because customer consumes electricity to get benefit. So this benefit will be reduced, eliminated, or postponed as a result of supply interruption. So the other concept assumes that some uses of electricity are worth more than others. The difference between the amount paid for the electricity and its worth to the customer is lost when supply is interrupted. So we need to know this difference is theoretically equal to the customer's willingness to pay to avoid interruption, or customer's willingness to accept compensation for having had an interruption. Whereas in direct costing method, this involves a worksheet that asks the customers to identify impacts of a particular outage scenario and then evaluate a monetary loss due to these impacts. This method is most effective for users where the losses are tangible and easily quantifiable, such as industrial customers. And this method has limitations for use in commercial customers and has higher degree of limitation for residential customer where the losses are more intangible. So direct costing method may not be applicable to residential customers. So how do we do this indirect costing method then? Indirect costing method based on economic principle of substitution value of replacement product or service is used as a measure of worth of product that was replaced. Means if you don't have electricity, what you will do? Get electricity from a diesel generator, or you will have lighting provided by candles, or you will have emergency lights, or you will get electricity from other alternative source. So you will be provided with those options, and you will be provided with those options and their cost, because the customers themselves may not be knowing all these things. So you as a surveyor, surveying entity have to provide those information to the customers. Then from there they will be finding out, they will be taking what they feel right, whether they are having electricity from alternate source or whether they are capable of keeping a standby diesel generator. It is their option. So they will tick that option and you will identify, or you will find out what is the cost they have chosen. Useful when social impacts or other less tangible consequences may contribute a large portion of the effect of interruptions. And survey respondents may choose from a series of preparatory actions that they might take in the event of recurring interruptions. So also you can provide, when carrying out survey, you will also provide options what preparatory actions the survey respondent will take, in the event of recurring interruption, means frequent interruption. If there are no frequent interruption, they may not go for any preparatory action. But if there are frequent interruptions possible, then they may go for some preparatory action. So the value of the preparatory actions provide an evaluation of the financial burden the customers are willing to bear to alleviate the effect of supply interruption. So what is the cost of that preparatory action? So that cost these customers are willing to bear, willing to take to alleviate the effect of electricity supply interruption. Means to avoid supply interruption, they are willing to take those additional costs. So that will also give us some indication of how much for higher reliability these customers are willing to pay. Okay, and before carrying out a customer survey, what we have to do? Electricity end use applications widely vary across the board spectrum of customers. So we know that it varies for residential customer, it varies for industrial customer, it varies for commercial customer, and within the industrial customer also there might be different categories of industries which will have varying consumption. So we need to know that fact. And interruption cost impact studies will be easier if these customers are grouped based on their use of nature of main business and use of electricity. Means industrial customers should be grouped in one group, commercial customers should be grouped in one group, residential customers should be grouped in one group. And we can also have subgroup. Means in industry, what type of industry? Whether it is a metallurgical industry, whether it is a food processing industry, whether it is a cement factory, or whether it is a brick kiln, there are different, or whether it is a vehicular industry or motor parts manufacturing industry, there can be several categories, So these industries can be grouped together, and within the group there can be subgroups also. In North America, they have a system, North American industrial and commercial, NICS they call, industrial and commercial industry identification system. So there they have categorized, what are the different subcategories of industrial customers, what are the different subcategories of commercial customers. So, and based on those subcategories, it is easier for the surveyor to categorize those entities, industrial and commercial, based on those categories, and carry out survey. So when you carry out survey, all these subcategories, should be represented, should be well represented, and according to their percentage share in the electricity consumption of a particular province or particular state or particular country. So for the purpose of developing the rate of using electricity, all the customers are generally grouped into major categories like residential, commercial, industrial, farm or agriculture, and the electricity tariff to the consumers are derived using different factors, including the worth of electricity to the customers. So when deciding on the electricity tariff or the rate of electricity, the worth of electricity to the customer is also one of the factors considered, apart from the investment cost made in the system. So to carry out a successful customer survey, these are the necessary steps we need to know. It is necessary to collect various information on the customers from the concerned electric utilities, customer categories and their numbers. So residential customer, how many residential customers are there within the jurisdiction of a particular utility? So how many industrial customer, how many commercial customer, so that we can know what is the representative sample for residential customer, for commercial customer, and for industrial customers. And what are the average annual consumption? Means average annual consumption for each customer category. What is the average annual consumption for residential customer? What is the average annual consumption for industrial customer? And what is the average annual consumption for commercial and other customers like farm or agriculture customers? Yeah. And what is the average maximum demand for these customer categories? And whether the loads are firm or curtailable. Some loads are firm and some loads are curtailable. So you have to declare at the time of getting connection whether your loads are firm or curtailable. So if loads are curtailable, these loads can get some rebates from the electric utility for curtailing their loads during the time of deficit of supply. And also hourly, daily and monthly variation of demand over the year that needs to be obtained from the electric utility. That information is readily available, and share of each category is in total consumption of the utility. So all of these information are readily available with the electric utility. So these information can be obtained directly from them, and they have to be obtained. Okay. So these information will be useful in determining the sample size, categories and subcategories of customers to be selected for customer survey. And the sample size selection is usually based on available resource and time frame. Obviously, if it is meaningful, then obviously the larger the sample size, the better will be the result. But again, you have to invest more resources, make available more resources for that. So, but you have to decide on that. Barring exception, the number of customers considered for survey is based on their share in total energy consumption. Means if there are residential customers considered, so their number will be high because their individual average consumption is low. So, and their share in total energy consumption is also high. For example, in case of Nepal, the share of residential customers is well above 40%. So in many countries it's near about that value. So the number of customers chosen for residential customers have to be very high, compared to the number of customers chosen for industrial and commercial customers, because average industrial customer will consume more. So to represent their share in the total energy consumption, the number of industrial customers chosen will be relatively far less, than the same category for residential customer. And rigorous and thoughtful discussions precede the questionnaire development, because questionnaire development phase is a very important phase. These questionnaires have to be prepared in such a way that they are able to information from the customers, and the customers should not feel that they are investing this unnecessary time when filling out these customers questionnaires, filling out these questionnaires for customer survey. So they should be willing to provide those information, so therefore the preparation of customer questionnaire is very important, very important, and it's time consuming, and lot of rigorous activities should precede before the customer questionnaire is prepared. Okay. And once the customer survey has been completed, we have the customer survey data. So from the customer survey data, what we get? Usually from the customer survey data, the customer survey provides information on broad aspect of electricity consumption by different customer categories in the supply jurisdiction under consideration. Okay, under consideration. The survey responses obtained have to be put under a database, and parameters like normalized cost per interruption, means what is the cost of one interruption to a residential customer, to a commercial customer, to a residential customer, that have to be obtained. Interruption cost per kilowatt, means what is the interruption cost per kilowatt of demand, that has to be identified. And interruption cost per kilowatt hour, means what is the cost of interruption per kilowatt hour, means what is the annual consumption of that particular customer and what is the interruption cost. So interruption cost divided by annual consumption will give us energy normalized interruption cost. So that will be computed using customer responses as well as the consumption information obtained from the competent authorities and sources. So these consumption information will be obtained from the electric utilities themselves, and other responses, and including the customer consumption response will also be solicited from the respondents, and we have to tally what is the data provided by the customers and what is the consumption data that is available with the electric utility, because electric utility, they bill the customers each month, so they have all these information, whereas the customers, they also have that information, but they may not be willing to look at those monthly invoices, and they will casually tell the surveyor that okay, this is my monthly consumption or yearly consumption. It's usually monthly consumption. So we have to tally those data also. And the normalized interruption cost per kilowatt is referred as the customer damage function and is computed for different customer categories. Okay, so customer damage function is nothing but normalized interruption cost per kilowatt, means interruption cost divided by the customer's annual peak demand. That will give customer damage function for the particular customer. Okay, and for that particular customer category, we have to find out the average of that that value. So customer damage function for different customer categories is called sector customer damage function. Means for one particular category, means if it is a residential, then this is the residential customer damage function, which is called sector customer damage function. Okay, so for industrial we have a sector customer damage function. For a commercial also we have separate sector customer damage function. For agriculture we will have separate sector customer damage function. For large office buildings like government institutions or academic institutions will have separate sector customer damage function. So we'll have different sector customer damage function for each customer category. No, this is a typical example. This is a typical example of a Canadian customer survey that was carried out in 1991. So that was a large scale exercise that was carried out by the pioneering institution in Canada for this type of studies. They carried out this survey for whole of Canada, and these are the, you can see, sector customer damage function. For residential you can see this is the curve, for industrial this is the curve, and for commercial this is the curve. And you can see that the commercial customers do have highest cost for interruption. Okay, highest cost sector customer damage function. So, and interruption durations are, these are the interruption durations. So in minutes. So this is for 2-second case. So this is for industrial and commercial. For residential, we do not have a 2-second case. So it is I think it's a 20-minute case here. So it's a 20-minute, 1 hour, 4 hour, 8 hour, 24 hour and 48 hour cases here. Yeah. So we can see that these customer costs have, different slopes by which they vary, they change. So obviously this may not be the case everywhere, but more or less it's like that, it's like that. So international practice of customer surveys, as per the SIGRI task force, this, the customer surveys, where these customer surveys were carried out, in which year, you can see this being carried out in Australia, Canada, for Denmark, Great Britain, So A stands for agriculture, C stands for commercial, I stand for industrial, this R stands for residential, and this L and I is a large industrial, and I maybe the medium size industries. So again here also A, C, I, O stand for office buildings. So these are the countries where these cost surveys were carried out. I don't see in this list the name of India, so I think these surveys may not have been carried out there. So more recent surveys were carried out, after this task force report was presented in Thailand, Italy, Norway, United Kingdom, and USA, and they come up with new values. So composite customer damage function, how do you calculate? Composite customer damage function is, prepared, or it comes out of the sector customer damage function. So this is the arithmetic combination of cost functions and composition weights of the constituent user group. So you can see here how composite customer damage function is created. Let's consider a load point with the following load mix. Residential customer have 40%, commercial customer have 35%, and industrial customer have 25%. And this is the result of the Canadian Electricity Survey, customer survey. So the same result that was plotted there, we are using these values. So for 1 minute interruption, average residential customer cost is, this much dollar per interruption. So it's very low. For 20 minutes, a little higher. For 1 hour, further higher. 4 hour, 4.914. For 8 hour, 15.69. And similarly for commercial, even for 1 minute interruption, this cost is little higher. And for industrial, it's further higher. And so on, So up to 8 hours. Yeah. And now composite customer damage function, we'll find out based on this, is composite commercial damage function as dollar per interruption. This is, and this is dollar per kilowatt. This is. So we have two different type of, So we will be using this CCDF value in dollar per kilowatt for further analysis to be made for value-based reliability investment decision to be made to invest in the power system reliability improvement. And so these are the plots of that. So for different customer categories, and this is the composite customer damage function we can see here. So the lowest one is the bottom one is for residential customer, and the top one, this one is the commercial customer. So again, this is CCDF dollar per kilowatt hour. So the interruption cost divided by annual energy consumption. This gives us CCDF in dollar per kilowatt hour. So this is interruption cost divided by annual peak demand. So this gives dollar per kilowatt. And then now let us consider the sample power system with a total generation of this much, demand of this much, and let us consider 5 different cases. One is the base case, where this is the generation and this is the demand. And the second case is base case plus this much wind generation added. Third case is seasonal derating of units in case 2. So here wind is added, but here derating is not considered, here derating is considered. Fourth case is adding 25 megawatt of firm import in case 3 in this case. And fifth case is considering maintenance in case 4. So obviously the units have to undergo maintenance, and the units will be derated also because of various reasons. Derating is a phenomenon by which a generating plant is not able to generate to its full capacity. So if it is a 100 megawatt unit is derated, then it can generate maybe 90 megawatt or 80 megawatt or 70 megawatt or anything, that is less than its rated value because of various reasons. That's a derating. So, and considering the maintenance, because you have to consider maintenance also, because every unit has to undergo periodic repair and maintenance. Okay, they have to undergo periodic repair and maintenance. So a certain time slot has to be allocated to carry out those maintenance activities. So therefore, these maintenance are carried out, and scenario analysis carried out using Monte Carlo simulation based program for all these 5 cases, which resulted in case 1 loss of load expectation 19.7 hours per year. Loss of energy expectation 2051 megawatt hour per year. Loss of load frequency 5.39, that much time. And this is a criteria again. This is based on this UPM is called unit per million. So it's 77.2, and E cost, that is the cost of interruption to the customers in the system. It is $17.18 million per year. And this IAR is nothing but this is the interrupted energy assessment rate, which is $8.38 per kilowatt hour. So this is the cost of 1 kilowatt hour of energy not served to the customer. That is called interrupted energy assessment rate. So for those 5 different cases, we can see this case number 5 is the most realistic scenario, because you have to include the maintenance and you have to include the derating of the units also, and those cases added means this wind power is added, and there is a firm commitment from import from another utility that also has to be added here. So you can see loss of load expectation is 71.1 hours per year. So here loss of load expectation is calculated in hours per year because we followed hourly load model. We followed hourly load model for the whole 8,760 hours. That is number of hours in a year. So therefore, this LOLE comes out to be in hours per year. If we had followed daily peak load model, then it would have been in days per year. And that days per year cannot be directly translated into hours per year by simply by multiplying by 24. No, you can't do that. Okay, so yeah. Sorry. Sorry, I think it got interrupted. Hello?
Yes, sir. Participants?
There was interruption, I think. Yeah?
No, it's working properly.
Oh, okay. I just didn't see, so I thought. Okay, let me again. Where it was. Okay. So see, these different scenarios are there. So for different scenarios, we have different reliability indices, loss of load expectation. Yeah, this looks like my internet is getting disturbed. Yeah. I think there is a disturbance in
Some bandwidth issue
my
is there.
side. Yeah.
You may hide your
So we
video.
can see that for
Sir, you may hide your video.
different scenario we have the LOLE. Are you hearing me?
Yes.
Dr. Srivastava?
Yes.
I think there was interruption in my side, I think. Yeah.
Sir, you may hide your video, sir.
Okay. Fine.
That will help.
Fine. Sorry. Okay, sorry. That's fine. Okay. Yeah.
Yes.
So now is it visible?
Yeah, it's visible, sir.
Okay, okay, thank you. So you can see for different scenarios, the second scenario has lowest LOLE value, because what we have done in second scenario is we had added 221 megawatt wind. Okay, 221 megawatt wind, and in third scenario we had incorporated, or we had included derating of the units. Means the existing unit can be in a state where they are not generating up to their rated value. So therefore, LOLE again decreases here in the scenario 3. Again in scenario 4, the LOLE value decreases because we have added 25 megawatt capacity. Firm import from neighboring entity means it is like adding a 25 megawatt unit in the existing system. So we had added this. Okay. So this again goes down to 14.9 hours per year. And in the fifth case, again this LOLE value, shoots to 71.1 hour per year, because we have also considered maintenance. So maintenance of all the units. So all of these units will not be available for the time required to carry out their annual maintenance. So for some unit it is a 2-week time, for some unit it may be 3 weeks time, for some unit it may be 1 month also. So for that duration, these units have to be kept out of the analysis because they will not be available. Therefore, this LOLE value has decreased over here. And corresponding to the LOLE value, you can see this loss of energy expectation. Where LOLE is high, loss of energy expectation is also high. Where LOLE is low, loss of energy expectation is also low. You can see here.
Excuse me, sir.
LOLE
Excuse me.
is 9.3 hours per year. LOE is 923 megawatt hour per year.
Excuse me, sir.
LOLE is.
We cannot
Yes.
see the PowerPoint presentation.
Oh, sorry. Let me again start this. Okay. Oh yeah, it's not seen here. Okay. So is it visible now?
Yeah, sir. It's visible.
Okay. Okay, thank you. Yeah. So you can see when the LOLE value is lowest, the loss of energy expectation value, or this is the expected value of energy net surge per year. So this also is lowest. When this LOLE, loss of load expectation, means what is the loss of load expectation? This means the system is unable to meet the hourly demand. Okay, so that is 71.1 hours per year, and the loss of energy expectation is highest, 7,845 megawatt hour per year. And similarly, we can see the loss of load frequency. Loss of load frequency, how many times there will be peak demand not made. Loss of load frequency doesn't mean that all the load in the system cannot be made. It says that whole of the load cannot be made, but part of the load is already made there, So when LOLE is 9.3, only 2.7 occurrence per year. When LOLE is 71.1, it is 16.41 occurrences. So similarly, the UPM value also corresponds to the LOLE value. You can see when LOLE is lowest, UPM value is also lowest. When LOLE value is highest, UPM value is also highest. Similarly, E cost is nothing but this is the energy cost. This is the cost of expected energy net surge. Okay, so that is highest in the fifth case and the lowest in the second case. But contrary to that, this interrupted energy assessment rate, you can see here, is highest in case 2 and lowest in case 5. So usually this IAR value is considered as constant for a given system, but you can see this slightly changes, not that much, but slightly changes for the system. When the system's reliability is very high, this IAR value is also high. When the system's reliability is poor, then the IAR value is slightly lower, in the lower side. Okay, so for a system analysis, this IAR value, once computed, will be considered as constant, and the same value will be calculated for calculating this E-cost value. So these costs have been calculated considering certain cost of the customer outage, customer interruption. So those customer interruption costs were obtained from customer surveys. Okay, so it is very important to carry out those customer surveys in a well-planned, well-thought manner, in a well-executed manner, so that the rates, the values that we obtain are credible and they can be used for planning purposes. So these values, the outcome of the customer surveys will be used in planning your power system. So how much capacity to keep, how much capacity to add, that will be determined based on those values. So it is the value-based reliability investment in a power system, because you are investing based on the value. Means what are the customers' outage cost value? So based on that, you will be making your investment decision. And you can see this is without considering the unit maintenance. So see what we call, that was the theoretical, curve that we had earlier. That was the investment curve. This is the investment curve here. And this is the unreliability cost curve. This is the unreliability cost, or we also called it E-cost. Okay, cost of expected energy not served. And this is the utility cost, that is the investment cost. And this cost is the societal cost or total cost given by this dotted line. So we have to operate at a minimum level somewhere here, somewhere at this point. Okay, somewhere at this point. So this was without considering the unit maintenance. So this lowest value, lowest UPM value, you have somewhere here. Yeah. But when we consider the unit maintenance, you can see this minimum has been shifted towards right side. Yeah, considering the unit maintenance. So no, sorry, I think I made mistake. So this is the cost without considering the unit maintenance, because this minimum is somewhere here. When the unit maintenance is not considered, the UPM value is lower. When the unit maintenance is considered, the UPM value is higher. You can see here, the UPM value is higher here. So when we consider the unit maintenance, we need to keep higher reserve margin, so the cost will be higher. When we do not consider maintenance, then we do not have to keep higher reserve margin. Therefore, the cost will be lower in that case. And yeah, you can see the comparison here. Total cost without maintenance and total cost with maintenance. You can see here. So we operate in this range. You can see from around 100 UPM to 200 UPM. So you have to, if you vary your outage cost or customer interruption cost, this curve will also vary, because if you change the outage cost, then this will cause change in this curve. Change in this curve. If you change the outage cost, interruption cost, this curve will be changed. So this will cause the change in this total cost curve also. So that will, your decision will be then changed. So as the cost of interruption changes, your decision has to be changed. And obviously, not only the cost of interruption will be changing, but also the investment cost will also be changing, because the newer units to be installed are costing more than the older units. So therefore, the cost also changes there. Yeah. So the conclusion: customer damage function needs to be obtained from the surveys and must reflect the increasing customers' dependence on electricity. The industrial and commercial customer sample size selection and usable response percentage are very critical to the successful outcome of the survey, because they form a very large share of the customers, and there are few number of customers but will have a large percentage share in the total energy consumption. The optimal reliability level for the sample system corresponds to 115 to 167 UPM with and without considering unit maintenances. More detailed analysis may result in the optimal UPM between 75 and 200 value. Investment in generation capacity must be justified from the outcome of the studies that point toward minimum total cost. Okay. So your investment in additional generation capacity has to be justified, because over investing in power system, over investing in generation capacity will result in higher cost to the society, to the customer, overall cost to the customer. Yeah. So therefore, it is not good to have over investment as well as under investment in any power system. Okay. So that's all. Thank you very much. So now your questions are welcome. Yeah.
निकाल सकते हैं.
Yes, please.
Participants may ask any query.
Yeah, sir, I have a question.
Mr. Vapesh.
Yeah. So can I go ahead and ask a question?
If
Yeah,
anyone
please
of,
go ahead.
Yeah, sir, when you mentioned that while estimating the interruption costs, so there are implicit and explicit costs. Now there are that for determining the cost, you said surveying is the best methodology to actually calculate these costs, right? But
Yeah.
the percentage of costs, like for example, the customer will not be able to come up with a tangible number with the cost, because most of the costs could be like for example the damage is like not tangible, and what is the typical percentage of the tangible cost that these survey methods may actually discount in determining the interruption cost?
No, actually, see, we have to, as I mentioned earlier also, we have to provide a questionnaire which which details what can be the possible tangible as well as intangible costs to the customer. Yeah. So we have to provide them with options. You can't say that, okay, you simply will not be asking how much will be your cost like that. You will, based on his or her consumption, you will be providing them with options. Okay, this is your consumption level, because we know that what is the consumption level and for what purposes that customer is consuming electricity, that we may guess only. We don't know. But when we have the questionnaire and the surveyor goes to the respondent there, then the customer will know what are the end use application he or she is having, and from that questionnaires content itself, it may be possible for the customers to answer in a credible manner. And obviously there are some responses that that will look out of out of the actual expected response domain. So we'll just discard them. Yeah. So yeah.
But isn't the methodology itself is leaning towards underestimation? Isn't it biased way of estimating these costs? To the lower side than actually getting the clear picture, because when we want to base our decisions on establishing the generating facilities based on this analysis, so how much is the discount to the lower side through these methodologies?
No, actually, see, when that will be, when processing the data itself, yeah, when we process the data that has been obtained from the customer survey, we will be analyzing each and every, customer survey, every responses, yeah. So the customers are provided with options, and these options, because the questionnaire itself, as I mentioned earlier, the development of the questionnaire phase, that is the most critical one, So we have to consider, what may be the perception of the customers regarding the electricity's end-use application, and what may be the potential cost. For example, you are disturbed, you have a loss of leisure time. So what is a loss of leisure time for you? So that can be, that can be guessed, or that can be gauged, because we live in a particular society. So it can range from this value to that other value. You can set a lower value, lower threshold for that cost, and upper threshold for that cost. So for example, I am living in Nepal, and I can't say that if electricity is not available for 1 hour, then I'll be losing around $100. No, that's not true. So that cannot be one of the options of the answers. So that's why in that range we will be providing them with that preset range. So that range has to be set by us. So it's not the customer that is setting that range, and based on that, from that range, customer will be choosing the value. Yeah. So there is no, I don't think there is the question of discounting or underestimating the cost of outage. Yeah, maybe sometime if we go to the willingness to pay or willingness to accept, there can be some divergence. As I mentioned earlier, that theoretically the willingness to pay and willingness to accept should coincide, but that doesn't happen. Willingness to pay is always less, and willingness to accept is always higher. That is a customer bias. We know that. Yeah.
All right. One last thing, sir. Is the quality of the power? Let's say there are no interruptions, but there are some damages due to inferior quality of the power. Does these studies, incorporate those, take those things also into the factors in any way?
No, in that particular, that the questionnaire that we actually incorporated, there was certain issues related to the quality of power as well, but the outcomes, these outcomes that I had referred, most of them were from the surveys that were carried out in the advanced economies, and the quality of power was not that a big issue there. So it might be in countries like ours, but in those advanced countries, that was not a big issue. Yeah.
All right, thank you.
Yeah.
Sir, I have a question. So, can I ask?
Yeah. Sorry. Go ahead.
So, what about the cost of ownership in related to reliability, improvement of reliability, cost of ownership?
Cost of ownership means
there is a linkage in reliability.
No, maybe you can type. You are not audible.
cost of ownership related to reliability journey.
No, cost of ownership means ownership of what?
Cost of ownership of any machine. Suppose in organization there are so many machines. Suppose the rolling mill, rolling mill, that is machine. So for that making and more reliable. So how the cost of ownership will involve the reliability?
No, it's as far as I, yeah.
Suppose some machine, suppose a rolling mill. I am the special thing that a rolling mill, I am working in a rolling mill division.
Okay.
So this machines cost of ownership of with relation to the reliability. So is it there interlink or is not required of the
No, yeah, as
reliability?
I mentioned. Okay, as far as I understood you, if I understood you correctly or not, let me, correct me if I incorrectly understood you. See, cost of ownership means if you have, as I mentioned, uh, you are procuring a machine or a device that is of high quality. So high quality means obviously when we say high quality, that means the product must be highly reliable also. Yeah, it is understood. So obviously the cost of product is intertwined or interrelated with the reliability itself. Yeah, but obviously for every product, if for electricity there is a as I mentioned yesterday also and today also, there is a optimal cost condition, optimal reliability you can find for electricity supply system because there is no bias. There are large number of customers there. But for a rolling mill, that particular owner may be the one customer only. Yeah. So there are no such mechanism by which you can determine, you can arrive at that optimal reliability level. So obviously there will be cost of reliability for each of the product that we have, but in absolute term, there cannot be any predetermined value of the cost of reliability itself. It depends upon product to product and case by case. It differs. Yeah. Okay.
Any other query from the participants? I don't think so, sir. Anyone further have any doubt? So, participants, can we conclude the session? Because this is the final session from Professor Karki. Okay, sir. It's fine.
Okay.
So, yeah, first, I'm thankful for your time and accept our invitation for delivering the valuable talk on the power system reliability, where you have covered a lot of important aspects, valuable aspects in this area. So participants maybe use your knowledge in their research further. Thank you very much, sir.
Okay. Thank you very much. Okay. Bye-bye.
All right. Participants, now it's the break time. We will start at 4 o'clock. The next session of Professor Verma